Good morning, everybody.
Good morning, ma'am.
Good morning.
Good morning,
Welcome
madam.
to the MC class. So already 9:05. Hope remaining will come soon. Only 74 has joined the class. Right, we'll start this session. Especially for our subject, we are not having the time much. So what we discussed in the previous class, we discussed about the channel hierarchy. Okay, the TDMA frame hierarchy of the GSM and also the channel hierarchy of the GSM. So how these are going to be helping us to accommodate more channels and the more uses to communicate within the prescribed GSM FDMA hierarchy or FDMA spectrums, right? So we already saw this particular frame hierarchy of the GSM. So what does the GSM frame hierarchy consists of? Nearly 2048 of super frames, 2048 of super frames having the periodicity of 3 hours, 28 minutes, 53 seconds, 760 milliseconds, accommodating that much number of customers assume. So this particular frame consisting of 2048 super frames is called as the hyperframe, whereas each and every super frame within the hyperframe, consists of again 51 26 multiframes or 26 51 multiframes. So multiframes are going to be consisting of number of uh, individual TDMA frames. Multiframes are consisting of number of individual multiframes. So we are going to be using either in 26 in number or in a 51 number, already we discussed in the last class. So that a particular multiframe may be consisting of either 26 in number or 51 in number, that can be used in again a particular number, that is 26 multiframes or 51 multiframes consist of 26 in number or 51 in number. If these can be what is called as segregated, or they are going to be collected at one place and can be arranged in number of 2048, that is they can be called as super frames, and this can be considered as the collected as a number, then if they are in number of 2048, they will be called as hyperframe. So if the super frames consisting of either 51 in number or 26 in number, using either 26 multiframes or the 51 multiframes, if they are collected in 2048 number, then it is called as an hyperframe, taking a periodicity of 3 hours and 28 minutes or 53 seconds and the 760 milliseconds. How these super frames are being framed on? Super frames are framed with the corresponding multi-frames. Super frames are framed on corresponding multi-frames. Multi-frames will be either available in 26 in number or the 51 number. Okay, so this particular multi-frames having the particular periodicity of 120 milliseconds, each and every multi-frame will be having a 120 milliseconds arranged in a number to form a super frame. And what the multiframes consisting of? These multiframes are consisting of collection of the individual TDMA frames. These multiframes are consisting of the individual multiframes, TDMA multiframes. What this multiframe, TDMA multiframe consists of? It is consisting of the 8 frames or the 8 radio carriers, 8 TDMA channels. So these 8 TDMA channels having the periodicity of 4.615 milliseconds. These 4.615 milliseconds, 18 number, are being collected as a single frame in a multi-frame. If these TDMA frames are collected in 26 in frame, then they are called as the 26 multi-frames. Or if they are collected in 51 in number, they will be called as 51 multi-frames. So 18 to 51, right? 18 to 51, they will be called as the multi-frames. If these 51 multi-frames are arranged in either in 26 in number, or if these 26 multiframes are arranged in 26 in number, then they will be forming as a super frame. If these super frames are collected in a number of 2048, they will be called as hyperframe. So in this way, the GSM is going to be accommodating 800 million people around the globe are going to communicate with each other. 800 million people are communicating with each other around the globe from 190 countries. So how could it couldn't be popular that much, as it is going to be accommodating these much number of people to communicate with each other parallelly along the two accessing purposes, that is either both in the FDMA and also in the PDMA, right? And coming to the channel hierarchy, according to the channels we've been discussed, the logical channels and the physical channels are available. Physical channels are being, arrangement has been seen by us. That is nothing but the corresponding frame hierarchy, how it is been arranging the channels, how it is been accommodating the channels physically to transmit the data along it, right? Coming to the logical channel, this logical channel is going to be providing you in different ways. That is what this logical channel actually, and in generally, all the channels are going to be appeared, or they are going to be formed in the type of logical performer or logical arrangement itself. So once the logical channels are arranged, or they are available, depending upon the transmission category and transmission speed and transmission type of users, you are going to change those logical channels into the corresponding physical channels itself, the corresponding physical channels, right? So here the logical channels are available in two categories. One is the traffic channels, and another one is the control channels, TCHs and the CCHs. So these traffic channels and the control channels are the two categories of the logical channels. Traffic channels are nothing but they are going to carrying the user information. Yeah, that is nothing but the encoded speech or the data defined by 26 frame multi-frame. So usually the traffic channels are going to consisting of the data frames in 26 in number. That is nothing but in terms of the 26 multi-frames itself, you are going to running the traffic channels to convey the user information, right? And next one is the traffic channels are also available in two categories, having the 26 multi-frames itself based upon the traffic rate. So how they are being conveying the traffic? They are going to be varied by the traffic rates. So we are having the full rate traffic channels and also the half rate traffic channels. So full rate traffic channels are going to have a gross bit rate of 22.8 kilobits per second, and whereas half rate traffic channels are going to accommodating you the half of the full rate traffic channels, that is 11.4 kbps, right? So these are the two forms of the traffic channels. And coming to the traffic channel hierarchy, the total traffic, what is called as channel hierarchy is being given here. The totally two categories of the channels we are having, traffic channels and the control channels present in the total logical channels, right? So traffic channels are again divided into speech and data. Speech has been available in two rates, half rate and a full rate. Data is available in three rates, 2.4 kbps, 4.8 kbps, and 9.6 kbps. And coming to the control channels are again divided into three categories, which are used by the corresponding GSM. Only the 51 multi-frames are going to be used for conveying these control channels, whereas traffic channels are used by 26. Okay. So already we've seen that particular traffic channels are being used by the particular 26 frames, and here the CCS, that the control channels are used by the 51 multi-frames. So again, those are being divided into three categories, that is broadcast control channels, and that is called as common control channels and dedicated control channels. The control channels are again divided into three categories, that is broadcast control channels, common control channels, and dedicated control channels. See this broadcast control channels are going to again having two categories, frequency correction and the synchronization. Broadcast is being completely exclusively for transferring the data, okay, and these particular control channels, broadcast control channels, are going to be provided with additional facilities. There is a frequency correction channel and also the synchronization channel. This frequency correction channel is going to be provided for rectifying the frequency errors, because of the neighboring channels. If there is any problem because of the neighboring channels, it will be get corrected by the frequency channels. And synchronization channel is being for establishing a connection between the BTS and also the mobile stations, right? That is a broadcast control channels, right? Broadcast, common, and dedicated we are having. Broadcast control channels are used to signaling the information within the within between the BTS and the base transceiver station, right? They are going to be working under the radio cell, and we are having the frequency correction to correct about, that is the correction among the frequency and information about time synchronization via the synchronization channel, where you are going to correcting in between the corresponding subchannels of the what is called as the base transceiver station and the mobile stations. So there could be some synchronization between the BTS and the mobile station, and there could be some frequency correction because of the remembering channels which are creating the disturbance while the transmission of the data. And coming to the common control channels, these common control channels are being therefore exchanging the connection setup in between the mobile station and the base station. Okay, to have the connection setup information to be exchanged between the mobile station and the base station, exclusively the control information. And this particular common control channels are going to be used in two ways. That is, paging channel will be used by the corresponding base transceiver station to choose the or to get connected with the appropriate mobile station. Whereas another channel we are having within the common control channels, that is the random access channel. Here, that particular random access channel will be chosen by the corresponding mobile station to set up a call or to get connected with the base transceiver station, right? Okay. And it is also having another additional one, which is called as the access grant channel, to signal a particular mobile station whenever there is a collision between the among the number of mobile stations to get connected with the base transceiver station. That is, whenever there is a scope of conflict between the mobile stations to get connected with the BTS, to connect with the corresponding transceiver, that is the receiver. Then as an alternative, we are going to using the access grant channel to signal the corresponding mobile station to get connected with either the traffic channel or with the standalone, okay, direct channel, right? So that is about the common control channels. And coming to the dedicated control channels. So this is the dedicated control channels are the bidirectional channels which are going to be used to get a connection or to have a standalone connection as related to the corresponding what is called as grant access grant channel. Similar to the access grant channel, we are also having a particular channel called as standalone dedicated control channel, which is the speciality of the dedicated control channel. Whenever there will be a problem of availability of the connection between the mobile channel, mobile station and also the base transceiver system, okay, either there is a failure in the connection between the traffic channels and the base transceiver system. As an alternative, we can use the standalone dedicated control channel with a lower rate, with lower signaling rate. Using this channel, we can send the data, but it also the lower signal rate. But we are having a disadvantage of compromising in the security. Why? Because it will not ask you your identification at any case if you are going to use this STCCH. So that security is a problem in using this particular alternative, right? And this particular dedicated control channels are going to provide you another two channels called as slow associated control channel and the fast associated control channels. This is slow associated control channels are going to exchanging the system information between the channels regarding between the two communication systems regarding the channel quality and the signal power level. Whereas the fast associated dedicated control channels are going to provide you the corresponding necessary handovers whenever there is a change of network between the two base transceiver system. Whenever there is a change in the networks of the two mobile stations, then handover is to be possible. For getting over that particular handover, and there is no signaling information and no particular connectivity in between the mobile stations, then also you can use this. But here we are being provided with the higher data rate. Why? Because why you are provided with the higher data rates is nothing but in the corresponding traffic channels, whatever may be the unused time slots remained unused, all those are being provided as the fast associated dedicated control channels, which will be used for this signaling the information between the TCH and the what is called as mobile stations and the BTS. And it can also transfer the large amount of data in between those stations, and can also be provide the handover between the networks, right? And coming to the GSM protocols, what we have to discuss in detail in this particular class, using this particular three types of services and three-tier architecture of the GSM and a particular TDMA hierarchy, that is TDMA frame hierarchy, using that particular channel hierarchy, how the corresponding transmission of the data will be done, whether there are any rules and regulations are there according to a particular proforma, how the data is going to be transmitted among the two end stations, that is the two terminals, using the network connectivity and using the corresponding architecture, using different subsystems like radio subsystem, network subsystem, and also the corresponding operation subsystem, various services we have seen like tele services, bearer services, and also the corresponding supplementary services which are helping the bearer and the tele services. And we're also having the different channels, both the broadcast channels and the traffic channels and control channels are having. Using these set of different types of channels and using having the different accommodation of the users using the TDMA hierarchy, TDMA accommodation, how the time is being slotted among the different users so that more number of users can be accommodated in the single frequency band, how it could be possible, and how in how disciplined way corresponding channels have been transmitting the signals over that particular architecture and also the channels, so that there should be some set of protocols to follow through the transmission of the data from the sender to the receiver, to follow through corresponding broadcasting and also signal broadcasting, and also through various channels, that is traffic channels and also the control channels. So how it could be possible, whether they couldn't be following any rules and regulations, they will be following the rules and regulations, they will be following certain protocols, and these protocols are being arranged and shown in this different way. That is the mobile stations on the either side, mobile station on the either side of the communication are having one set of protocols, whereas the corresponding base station controller or also the base transceiver system through which the mobile stations are being get connected to the network are going to following certain other set of protocols, right? We are going to see different, there is a mobile station is having some CM, MM, one second, somebody are being having noise. Right. So this particular mobile station is having a particular set of protocol. A protocol stack is different from the corresponding protocol stack of the base transceiver system and the base station control. So what this mobile station is consisting of, CM, MM, RR, LA, PD, and radio, and what are these? And again, what is this BTS is consisting of? RR is having in common with these two, BTSM, LA, PD is common, and radio and PCM. What are these? All these things. Right, and the interface is already, you know that mobile station has been connecting with the BTS using the EOM interface, and base transceiver system is going to be connecting to the base station control to the ABIS interface, and base station control is connected to the MSC or the mobile switching center through the interface of A with variations in the speed. And this interface is having the 16 or 64 kilobits per second rate, whereas the A interface is having the 64 kilobits per second or 2.048 megabits per second. So, okay, so these are the protocol stack that is being arranged in between the mobile station, base transceiver station, and the base station controller in the mobile switching center. So all these are going to be having a various set of protocols, what they are going to be using, what are the different set of protocols they will be using, we will see through. Right. I think you noted this particular protocol structure. GSM protocols. Everybody note down this particular protocol structure, and I'm going to explain you this particular set. So only 3 layers are going to be helping for us in communicating among the mobile stations. So 3 layers of protocols are going to be helping us. So the first layer is the physical layer that is going to helping us the radio specific connectivity and the functionalities, that is the creating of the bus and sending over the signals, okay, and multiplexing of the bus and for accommodating that particular bus into the TDMA frame, and synchronization with the base transceiver system, detection of the channels, and sending the corresponding measure so what is called as burst among that particular channel by measuring the uplink and downlinking frequency. So what is nothing but the physical layer is nothing but it is going to be the first layer is the physical layer, and it is going to be concerned about the radio specific functionalities, that is nothing but creating the bus, accommodating the bus into the TDMA frame, and synchronization, getting synchronization with the base transceiver system and multiplexing the burst among the multiple connections. Okay, that is about the layer 1 and layer 2. So what the layer 2 is going to taking care about, it is going to be doing the signaling between the GSM networks at the higher layers. For this purpose, it is going to be using the LAPD protocol. So LAPD protocol is the link access protocol from the D channel. Already you know about this. So this particular protocol will be used by this particular layer 2 in order to get connected with the, to get signaling in between the GSM network entities, right? This is a version of the HDLC. LAPD is the link access protocol D channel. And coming to the layer 3, this particular layer 3 is going to be used for different, that is, this particular layer 3 is being divided into several sub layers, and this will be among the particular sub layers. The lowest sub layer of the layer 3 is the RF. It is nothing but the layer 3 is nothing but our network layer. So we discussed about the physical layer, which is concerned about the radio connection activities, creating the bus, accommodating the bus into the TDMA, and get synchronizing with the BTS and accommodating the particular TDMs onto the channels. And layer 2 is concerned with the signaling in between the corresponding GSM entities using the LAPD protocol, link access protocol from the D channel. And coming to this layer 3, it is of the network layer, which is divided into sublayers of different categories. The lowest sublayer of the corresponding layer 3 is the RR. If you see the diagram, if you can observe the diagram, you can identify it. Right. The radio subactivities of the physical layer, LAPD layer of the second layer, LAPD protocol of the second layer, and the corresponding 3 layers are the network layer entity is been divided into the sublayers, whereas the lowest layer is the RR here, right? So RR layer, that is nothing but the radio resource management. The lowest sublayer is the radio resource management, and the functions of the 1 minute. Okay. So the functions of RR could be the radio resource management. It is going to be supported by the BSC. The functions of RR are going to be supported by the base station controller via the BTS management module. So BTS management module, that is the BTSM. So that the RR is going to be getting communicated with the BTSM of the base station controller, right? We'll see in the diagram. So BTSM is being located here. So using this BTSM, it is going to be communicating. The RR is going to be reflected with the BTS, and BTS is going to be communicating with the BSC with using this BTSM. Right? The RR is going to be managed with this particular BTSM, base transceiver system management. Right? So that is about the RR, that is radio resource management, how the radio signals are available, whether the signals are properly available or not, whether the proper mobile station has been connected to the corresponding BTS or not, whether the BTS systems get synchronized with the corresponding mobile station. All these are going to be set up. Okay. So what is this? The main tasks of RR: setup, maintenance, and release of radio channels. So getting it with the call, that is getting the signals, radio signals, and maintaining of that particular call, and releasing the radio signals once it is been done. And coming to the section of the third layer, section of the third layer, what it is going to do? It is going to be doing the mobility management. Contains the functions like registration, authentication, identification, location updating, and provision of a temporary mobile subscriber identity, that is TMSI for our subscriber, right? This TMSI is going to be doing the temporary mobile subscriber identity. Whether it is been TMSI will be permanently with the SIM, but whenever you are being raising the call, that particular TMSI will be separately noted by this corresponding GSM, right? The protocol version is going to be noting as the temporary mobile subscriber identity, which is being noted while the call is being making. So that while the call is being raised by a subscriber, the mobile management is going to be taking care of registration and authentication and identification, and also location updating of that particular subscriber and provision of the a particular identity number to that particular subscriber, that is called as TMSA, right? RR is going to providing you the radio resources, setting up your call, maintaining and releasing your call. And finally, the mobility management is going to performing you the functionality of the subscriber identification and subscriber logging and whatever it is, all his details are going to be managed by the mobility management. And coming to the layer 4, that is of CM. Okay, so that the layer network layer is being divided into, sorry, layer 3 itself, I'm sorry, it's been layer 4, it's been given as, it's only layer 3. It has been again divided into our 3 categories, that is MM, RR, and also the CM, mobility management, resource management, and the call management. And this particular call management consisting of 3 entities, that is the call control, short message service, and the supplementary services. So call control, how the call will be get engaged between the 2 subscribers, what is the whether they are going to use the short message service in between them, and if any supplementary services are being required by like this, whether there is any tariff charges to be given, any location identification has to be given. These are the supplementary services we discussed about. All these are being provided by this call management section, right? Already you know about this SMS, short message service, and this is going to be allowing the message transfer, you know about. But how this particular SMS is going to be working with? This particular SMS is going to be working with the help of SDCCH and SACCH. SDCCH is the slow dedicated control channel. Using the slow dedicated control channel and also slow associated control channel, our SMS is going to be working. While the SS, that is nothing but the corresponding short service, is going to be offers the services like user identification, call redirection, or forwarding of the ongoing calls. So user identification, call redirection, and the forwarding of the ongoing calls are also going to be provided to you by the SS module. This particular SMS services is going to be followed through the control channels, that is the standalone dedicated control channel and also the slow associated control channel. Okay, and coming to the CC, this particular CC section, right? There is nothing but the call control. Supplementary service is going to be provided by this particular SMS, and whereas call control is going to providing a point-to-point connection between the 2 terminals and used by the higher layers for call establishment, call clearing, and also change of call parameters. That is, you may be changing the call from corresponding speaker to the mic and mic to the speaker, and you are going to reducing the volume, how you are going to changing the parameters of the call while the call is going on, whether you are going to clearing the call, that is, we are terminating the call, whether you are establishing the call, whether you are adding the call with some other, not only calling the single person, you are going to call a group of persons. So how you are going to change the parameters, how you are going to establishing the connection between one user to the another user, that can be done with the call control, right? See, coming to the data transmission, where how the data transmission will be done at the physical layer. So at the physical layer, we are being considered about only the radio transmission and data picking. How the data transmission will be done? Data transmission will be done typically using the pulse code modulation system. This is one of the modulation. Actually, we discussed about this particular modulation, whereas the digital pulses will be coded. The digital pulses will be coded into the bits. According to that particular bits itself, the data transmission will be done here. And at LAPD is used for layer 2. At ABS already we discussed about this particular one, how it has been managing the base transceiver management system. And signaling system SS7 is used for signaling between MSC and the BSC. So how the mobile switching center and the base station controller are being communicating. This protocol, that is SS7 protocol, is going to be used for signaling between the MSC and the BSC. This is going to be transferring all the information between the mobile switching center, HLR, VLR, authentication center, AR, and OMC. Already we discussed in the architecture, right? It is also going to be controlling the BSS, that is the base station system, using the base station controller. See, you can observe this SS7 in this particular protocol section. All are being similar, right? BSS is the base transceiver system application protocol. base transfer system management, whereas all are similar among it, whereas SS7 is for meant for BSc and the MSc here. That is the base station controller and the mobile switching center are going to communicating use this SS7 protocol, where it has been communicating with all the sections of the mobile switching center of NSS system. That is the VLR, what is called as HLR, authentication center, ARR are going to be communicating and controlled using this SS7 protocol, right? LAPD is going to be used for communication between the mobile station and the corresponding base transceiver system. All are being discussed here. Radio resource management, mobility management, and the call management. It is between the MS and the BTS. And whereas the physical layer communication is commonly between all the systems using the pulse code modulation. And BTSM is going to be managed by the radio resource management. And BSCCAP is nothing but the base station base station subsystem or base station subsystem application protocol is going to be managed using the BSC in between the BSc and the MSc here. And CM and MM are common between all the other layers, I mean both the end systems. And SS7 is used to communicate in between and get control all the components of the corresponding NSS subsystem through the A interface in between the base station controller and also the mobile switching center, right? So that is about the corresponding protocols used in the GSM. The protocols are being served by the three layers, basically physical layer and the corresponding second layer, that is the data link layer and the network layer. Only these layers are being served by the mobile communication system to transfer the data in between them, whereas the protocols that we discussed here is the LAPD and the SS7, okay, this particular layers, and whereas PCM is being used in the physical layer for transmitting of the data in coded form, right? And coming to the localization and calling. Localization and calling. So what is this localization and calling? In the GSM system, the fundamental feature of the GSM system is going to be the users are going to be localized automatically, irrespective of the particular area. Irrespective of the particular area, all the users are going to be get localized. There is without irrespective of the region, they are going to be existing, where they are being existing, whether they are being locally existed, whether they are being locally aparted or non-locally aparted, where they are distant aparted. All these are going to be identified, for which the corresponding periodic location updates are going to be done. That is, worldwide localization of the users are being done using the periodic location updation. For that one, the HLR will be used. That is, the home location register is going to be updating your current location. And obviously we know about that visitor location register is going to be what is called as, it's going to be logging your details. Temporary subscribers and also the permanent subscribers are being getting recorded by the VLR, right? And this particular MS is going to be informing the HLR about the location stages. That is, the mobile station will not be constant at any time. It is going to be moving, okay? That particular mobile station is going to be moving and it is going to be informing the HLR each and every time and changing VLRs. That is nothing but whenever you are going to be changing the HLR, whenever you are going to be changing the HLR, obviously the VLR is going to be changing your identity. Whether you are the local one or whether you are a non-local, whether you are temporary subscriber, whether you are the permanent subscriber, that could be identified by the VLR. Changing the VLRs with uninterrupted availability is called as roaming. What you are knowing about, you are simply calling it as a roaming. So how that particular roaming? Previously, you are going to having the roaming charges, right? Depending upon the distance you are being aparted, depending upon the distance you are aparted, whether you are presenting within the district, within the state, or within the country, depending upon that, roaming charges are used to be bared on your call, right? Depending upon the distance you are being apart, whether you are belonging to the same district, whether you are belonging to the same state, or whether you are belonging to the same country, depending upon that you have made on the call, you made the call, the roaming charges are going to be parted on your call. That particular roaming charges, in addition to the call charges, that particular roaming charges are used to be bared on your call. But today, you are not going to have that particular differences. All are being just resolved. But previously it is used to be. But how you are going to identify that the call is belonging to so-and-so area, whether you are that particular call is local to your area, not local to your area. that could be identified by that particular localization procedure. What you are going to do in this localization procedure is, whenever the mobile station is going to be moving and it is going to be mobilizing, its identification is being done by the HLR each and every time. That is nothing but the mobile station itself is used to give its identification to the HLR each and every time. The HLR is going to be updating the VLR. According to the identity or location that you have been existing, that is being updated by the mobile station to the HLR, the VLR is going to be changing you from the temporary subscriber to the permanent subscriber, or permanent subscriber to the temporary subscriber. In the category of the temporary subscriber, you will be identified as a local or non-local. Even within the permanent subscribers also, you will be having the permanent and the, what is called as local and the non-local subscribers. But whenever you will be the temporary, obviously you will be first identified as whether the local subscriber or the non-local subscriber. So that particular changing of VLR's log, changing of the VLR's log depending upon the mobility of the mobile station without any interruption in your call, changing your identity and changing your localization is called as the roaming. How that particular identification will be done, the procedure included in that particular localization of your mobile station while you are moving over it, while doing your call, is called as the roaming, right? So roaming can take place within a network of one provider or between the two providers of a country or different countries. What we discussed, I already discussed it with you. It may be between the network, and maybe between the country and the country, or the place and the place. The roaming may be varying. The roaming may be varying between the network and the network, and the place and the place, and the region and the region, and the country and the country. Whatever may be, it can be taking place at any category, between the any categories. We can say that it is a roaming. Okay, so to locate an address and MS, several numbers are being needed. So how do you have been identifying how this particular localization will be done by this GSM? So it can be doing the world globalization and world localization among that much number of millions of users by using this particular roaming procedure. How you can identify a mobile station? How you can identify the mobile station? By using the several numbers. Several numbers are needed for identifying the mobile station to identify this localization and the roaming. So whether there may be the roaming between the network to network, there may be roaming between the country to country, or a state to the state. So for that one, we need certain numbers in order to identify the corresponding mobile station. So we'll see what are all these numbers that are needed for the corresponding roaming procedure. Right. This particular numbers that are needed for roaming are mobile station international ISDN number. Mobile station international ISDN number, that is called as MS-ISDN. That is the first number. The only important number for a user of GSM is the phone number. This number consists of the country code, that is the MS-ISDN. That is nothing but the mobile station international ISDN number is nothing but the our mobile number itself. Mobile station international ISDN number is nothing but the our mobile number. It is consisting of the parts within it, indicating the corresponding country code, that is CC, and the national destination code NDC, and the subscriber number SN. Right? So the MS-ISDN is nothing but the mobile station international ISDN number, which is nothing but the corresponding phone number given for you, and that particular corresponding phone number itself consisting of what it is consisting of country code, national destination code, and also the subscriber number. All these are comprises of your mobile number, right? All these three numbers are being comprises of your mobile number. It's nothing but your mobile number having the country code, having the national destination code, and having the subscriber number, which is the MS-ISDN, right? This will be for one of the identification. Next one is international mobile subscriber identity. International mobile subscriber identity, IMSI. This IMSI will be used for internal unique identification of a subscriber. Okay, this is the identification of a mobile number, and the location identification, and the country identification, and subscriber number also. But unique identification of the subscriber will be done using this international mobile subscriber identity, that is IMSI. And this is consisting of again the mobile country code. This is the mobile country code, that is MCC. Whereas this MS-ISDN is consisting of only the country code CC. Here this IMSI is consisting of the mobile country code MCC, mobile network code MNC, and finally the mobile subscriber identification number MSIN. So please note all these things. Don't forget all these things, right? What is this numbers for? Say for example, if you are been working with any telecommunication department, even though it is been software section, and your client project is having the telecommunication, what is called as tariffing, telecommunication designing, and telecommunication rating of the calls, on designing of the calls, then you are going to able to know all these things, right? So that you have to identify, you have to remember all these things. That is, if you have been working for an Apple, or if you have been working for any Samsung company, you have been working in the telecommunication department, then you have to identify all those things, right? That is mobile station international ISDN number and international mobile subscriber identity. This is for unique identification of the subscriber, consisting of the internal subcodes called as mobile country code and the mobile network code MNC, and finally the mobile subscriber identification number MSIDN. Sorry, MSIN. Sorry. And for another numbers are the temporary mobile subscriber identity, which will be denoted by the VLR. That is, we know about this. That is TMSI, temporary mobile subscriber identity. To hide the IMSI, that is, we are not going to be exposing this particular IMSI, that is internal mobile, sorry, what is called as International Mobile Subscriber Identity, IMSI, to hide the IMSI, which would give away the exact identity of the user. So to hide our location, we are going to be hiding the IMSI. So we are going to be signaling over the TMSI. Using the TMSI, you are going to be subscribing, whereas you are going to be hiding your original IMSI, right? So this particular 4-byte TMSI for local subscriber identification, you are using the TMSI. You are going to be hiding our IMSI. So each and every time your smartphone is going to be asking you whether you are able to give your location identity. You are been hiding each and every time. So hiding the location is safer when compared to the exposing your location. So whenever you are exposing your location, you are being using the IMSI. So simply it doesn't know that what you are doing at background. Whenever you are getting the location on, that is, you are being putting the location on nothing but you are giving the IMSI of your number. Otherwise, if you are being not giving the location identity, then you are being hiding this IMSI, and you are going to be using the TMSI for your subscribing of the signal or subscribing of any app. Next one is mobile station roaming number. Mobile station roaming number. This is another temporary address that hides your identity. This is the another temporary address that hides your identity, and you are a subscriber also. That is MSRN. The VLR generates this address. That is nothing but the visitor location register is going to be generating this particular address, mobile station roaming number MSRN, from the mobile switching center, and it is going to be stored in HLR. So that from the HLR itself, the VLR has to be get identified, right? From the HLR itself, the VLR gets the identification of the corresponding subscriber. Okay, so that particular VLR has, before the VLR is going to be getting updated your identification, the HLR has to be get updated your identification, whether it is the hidden identity or the original identity. If the original identity is being given, that is only been updated in the VLR. So that if you want to hide your identification, if you want to change your MSC, that is the mobile station is also going to, mobile switching center is also to be hidden with the corresponding mobile station, then you are going to raising this MSRN. That is, it is going to be hiding your mobile station center or mobile station identity also. Not only your mobile number, your mobile station control identity is also going to be hiding by using this mobile station roaming number, which has been generated by the MSC and been stored in the SLR. What this particular mobile station roaming number consisting of? This particular mobile station roaming number consisting of current visitor country code, the visitor national destination code, and the identification of the, these two codes will be present in the MSRM. That is what they are being consisting of: current visitor country code, current visitor country code as it is a temporary address, and a visitor national destination code. Simply the national destination code will be given. That is the visitor national destination code. These two comprises of the MSRN, mobile station roaming number, right? And this particular MSRN helps the HLR to identify the incoming call. This is going to be identifying you the HLR to find the subscriber's incoming call, right? So this ends our localization and calling, and there is one procedure mobile terminated call, which will give you the complete picture of how you are going to making call and what happens, what are all the steps. We'll see in the next class. Time is up. Okay, so I'm leaving the session. So what you have been discussing from where the call has been raised, how the HLR been updated, how the VLR been updated, when the corresponding identity will be given, when the corresponding identity will be hidden, what the call will be tracing through the path, what is the path of making the call from one station to the another station, will be given in a single picture like this, mobile terminated call, MTC. Okay, there are different steps how the call is been moving over, how the subscriber has been requesting all these sections to make a call and to talk with his friends and all those things. We'll see in a single picture in the next class, and we are being reminded with the corresponding handover, next the security and the GPRS. Okay, we'll end with this particular week with the first unit, and time is over. I am leaving here. Thank you.